Hello everyone, I'm Giovanni, and today I will talk about how to refactor ReSwift application in order to make them modular. I would like to begin this talk with just a few words about me and about the company I'm working for. Just few, I promise. I'm a senior iOS developer at PhotoC. I will talk about PhotoC in the next slide. This is my first talk in Swift Heroes, and I'm very excited to be here today. This is also my first talk in English, so apologies in advance for my mistakes with language. Thank you. I'm a functional programming lover. I faced into functional programming topic at first year at university, and since that time, I've never stopped learning about it. Here you have some contacts to contact me, of course. Joav on Twitter. If you want, you can follow me. And on GitHub, you can find me as Joav90. So let's talk about PhotoC. PhotoC is the leader in Italy in printing photos, photo books, and everything regarding the world of photos. It's very interesting and growing reality. In fact, it has been grown by 3 times during the last year. And if you're interested to see the application in which I'm working, I put here a QR code. You can download it. It's free. You can download it, I promise. So let's start with the talk. Let's see the agenda of today. First of all, I want to spend just a few words about ReSwift. Do you know what is ReSwift? Raise your hand if you have ever used it. Okay, Redux. Someone? Okay, Redux is better. Don't worry if you don't know about it, but because I prepared some introduction to it, so I will try to be slower as I can. The second topic we will cover will be modularization. Do you know about modularization? I think it's a more popular topic. Okay. And then, after that, after a brief introduction to modularization, we will see a simple application written in ReSwift and in Swift UI. And the goal, the aim of this topic, of this talk, is to modularize together during this talk this simple application. Last but not least, a little recap of what we saw and time for questions, of course. Let's start with ReSwift. ReSwift is a framework that gives us the superpowers to create Redux-like architecture in Swift. But what is a Redux-like architecture? A Redux architecture is our architectural design pattern that splits our applications, our load sections inside the application in 4 parts. The first part is the view, which of course represents the presentation part of the app, so the most visible part, let me say. The views has the power to dispatch actions, which are events that can be sent, for example, after an action of one user, for example, tapping on CTA, a button, and so on. Or something can be sent can be triggered by something driven by view lifecycle. For example, when a view appears, I decide to download some data from some backend. Actions are intercepted, received by another component of the architecture, which is the reducer. Actually, there is more than one reducer inside the app, and they are special functions that computes a new state on the basis of the current state and the action received. In the end, not less important, of course, we have the store, which is the point in which the states are stored, as the name say. If we put those components inside a diagram, we'll see that And we try to, of course, draw an arrow between the components, drawing the flow of data. We will see one of the most important benefits of this kind of architecture, which is the unidirectional data flow. I saw in other talks that was mentioned too for MVVM, for example. Why this is a benefit? This is a benefit because, I put it in the benefits, it's easier to debug something wrong on data when you know from where your data comes. So this is a good benefit of the Redux architecture, of course. We have also other benefits. One other benefit is the code organization. Redux is very constrained to these 4 components, let me say. So basically, if you want to follow this kind of architecture, you will be constrained to implement every time the same, let me say, skeleton of components. This is good because, for example, I saw it in my own life. For a new developer, starting developing on an already created application with Redux architecture, it's easier in some way. Another benefit, for example, is that, remember I said before, reducers are a special function, and all the logic that computes the states stays on reducers. What kind of special function? Someone mentioned also this topic. They are pure function, so function that from one input always return the same output, and moreover, they don't have any side effect. So you understand that it's very easy to test a function like this. This is a good benefit. This is okay, but there are a lot of frameworks nowadays that exist to create a Redux architecture. Why we should use ReSwift instead of, for example, Composable Architecture or other frameworks? Well, ReSwift, the main reason is that ReSwift is the most started framework on GitHub. So it's the most popular. I guess it's also the oldest one, because if I remember, it has been released for the first version in 2015, I guess. So it's very trustable from developers, because there are more than, I don't know, 7,000 developers that already use that. Another reason to use ReSwift is that ReSwift is platform independent. So we can decide to use it in our macOS app, in our WatchKit app, in our iOS app, and so on. But ReSwift has also some drawback. Actually, not only a drawback, it's a sort of benefit, but it's a drawback for our purposes today. There is this one in the slide. All the app relies on a global app state. This is good. Why? This is good because we have a single source of truth for our application, but this is also a problem when we want to modularize it. But why we should want to modularize our code? What are the benefits of modularization? A lot of questions today, I know. Let's see this in particular, but before answering to this question, I want to do an overview on what is modularization. So, modularization, I copy-pasted this definition, I don't remember, maybe from Wikipedia or Google, is the activity of dividing or splitting a system into submodules in a way that they are interchangeable. What does it mean? It means that if we have a huge, giant blob application, modularizing it means that we want to split by topic, reasonable topic, I guess, in subparts of the application in order to reduce the size of the application and gain a lot of benefits. What kind of benefits? The first one, I already said before, is interchangeability. Think about it. We saw talks about feature flags and so on yesterday. With a modularized application, we can easily change one module with a new module. For example, if we want to create a new network module that uses the new Swift concurrency API, and we want to change the old Objective-C network module with this one, it's very easy. We can work in a parallel way. We can create the module, and then we can send in production the new module. And maybe with the feature flag, we can create a sort of fallback in case of any error, I don't know, any bug. Another benefit is isolation. Each module is isolated from the others. So this means that, of course, every time we change a part of the code, every time we decide to, I don't know, implement a new feature, we don't have to touch the entire application. We can simply work on the module impacted, reducing the risk of regressions and so on. Of course, there are also other benefits. Modularized code base, it's easier to debug. Because, for example, in Swift UI, we can provide for each module a simple playground with a live view, and we can run simply directly the view with all the mocked stuff we want. It's also easier to test. I'm talking about not only unit test and UI test, but also real test, I mean feature test. Okay, now it's time to see our simple application. I created this simple application that is called Kittens, and as I said before, this application is written in ReSwift and Swift UI, so Redux architecture using ReSwift, but it's not modularizing it. The goal of this talk is to try together to modularizing it, and see what are the problems we found, and find a solution to the problems we will found. So, Kittens, it's a cute, simple application that shows photos of kittens, of course, and tapping on the photo provides a detail with some information such as the categories and the breeds. As I said before, it's written in Swift UI. Of course, you can apply the same things with an UI kit application and so on. So I will focus just on the list because it's a waste of time to see also the detail, but because it's the same basically. So we can see the code of how it is implemented the list, and then we will modularizing it. So let's start from the view. The view is a simple Swift UI view with a view model, which is, of course, an observed object, and an initializer in which we pass the store of upstate. This is the first element from ReSwift. The store is declared directly in ReSwift. Of course, you see here that the store is referring to the entire upstate and not to a local upstate. We will see it later. And basically, inside the initializer, we create the view model, initialize the view model, passing the store. And then we have a body with some Swift UI implementation. We already know Swift UI, so we don't have to see that. Let's go to the view model. The view model is very simple. It provides two published vars for updating, of course, the Swift UI view, and a stored variable, immutable variable, which is the store. That is the one passed by initializer. You see now from the diagram above, sorry, that time, the view, it's, now we are still in the view part of our architecture. Just because the view model is something that in our Redux architecture stays inside the view part. So we haven't dispatched any action at all. We can do that, and of course we will do that, using a function declared in the view model. In this case, I created a fetch catalyst function, which basically dispatch the action using the dispatch function of the store. In this case, the action dispatched is the fetch cats action. Actually, the fetch cats action, it's a special action in this case, because it's something that has something like a side effect inside it, because of the asynchronous API call to the cat API, of course. So ReSwift handles this kind of stuff in a lot of ways, but they suggest to use an extension library which is called ReSwift Tank, that basically adds one component to our diagram, that is the middleware, that has the aim to catch the asynchronous action, which is called Tank, we will see in the next slide, and execute it. And then we will see it. I don't want to spoil it too much. So, as I said before, we must create the new middleware which will catch the new action. And we can create the action. The action is a tank of catalyst state in this case. And a tank is a special action that has the capability to dispatch other actions. So inside the encapsulation of the side effect. So I pass a function inside the initialized of the tank, and here, if you see, the first thing I do is dispatching a fetch action, and then I create a task. The task, of course, will have the closure marked as main actor to come back on the main thread, of course. And inside the task, I will perform the server code using a wait, of course. And then after getting the result, I will dispatch another actions. Those two actions are the basic action by ReSwift. So as I said at the beginning, they are received by the reducer. The reducer catch the action, and it is implemented like a simple switch on the actions, in which for each action received, I decided to assign a new state. And I return the state assigned, of course. For example, for the fetch action, I want to set the variable loading to true, because I want to show the spinner in the view. The same for the list. When I receive the list, I set the list. I marked this stuff in the diagram above as a step of the reducer and the store, because as I thought before, the store is something provided by ReSwift, and basically we don't have to do anything. It's all handled by ReSwift, and it's okay in this way. You see, the reducer is a very simple function. And then we come back to the view. The view receives the updates from the store using a subscription. In particular, ReSwift provides a protocol, which is store subscriber, that lets us implement this method, which is a new state, and it's called every time a new state is dispatched by the store. In the end, this is the app initialization. It's a simple Swift UI initialization. The only difference is that we declare a global variable for the store, and we pass it to the view. You see here, when we declare the store, we pass two parameters. The first one is the app reducer, which is a combination of all the reducers of all the sections. And the second one, of course, is the state. It's the initial state. The third one represents the list of middlewares. So it is the middleware we created before. Finally, we have saw everything about the app. I think we are ready to modularizing it. Are you ready? Yeah. Perfect. You are not sleeping, okay. Let's start modularizing it. I want to split the modularization step in 4 parts. The first part is the creation of the new Swift package. Of course, we don't have to modularize using, we are not forced to use the Swift package to modularize our app. We can use a static framework, dynamic frameworks, and so on. We can even create folders inside our project, but I like Swift Package Manager, and I want to do it with them, with this tool. So, second step, it's obvious. Move all the catalyst file inside the new package we just created, because modularizing means move all the files inside a new world, which is the package. Third step, it's make the new package just created building, of course, changing some line of code. And last but not least, we have the we have to build the entire application. Let's start with the first one. Creation of the new Swift package. You can do it in a lot of ways. Once upon a time, there was just one method that was the terminal, but now we are lucky and we can use Xcode, for example, or Visual Studio Code and so on. I created, once we created using, for example, Xcode, we will see that we will have a Swift package.swift file, and we can edit it, for example, setting the name, in this case, Catalyst, because I'm not fantasy. The deployment target, iOS 15, because I want to try all the newest technologies. Some dependency, for example, ReSwift Tank, as I said before, but also some internal dependencies, such as the network, because you know, if we put a new all this stuff inside a new package, of course we should share a network package between this package and the old application, because we have also the detail to get work. So this is the first step. Second step, very easy. Move all the files, the Catalyst files, inside the new package. Basically, drag and drop all the files from the main project to the sources folder of the new package just created. And then, of course, if we want to get our life complicated, add the missing imports when needed. I don't think there are missing imports, but it's okay. If there is some missing import, add it. Third step, we are ready to go to the third step, which is make the new package build. Here comes the first problem, because remember, we are passing a store of app state inside our module. What does this mean? This means that try to building the new package, we will see this kind of error. Cannot find type app state in scope. This is understandable. We don't know anything about the app state. We are in the world of the Catalyst package. So furthermore, we don't have just this kind of error. We have a lot of errors everywhere. We have the definition of the app state, of course. So what is the solution to this problem? One solution can be the most simple. Instead of using the app state, we should use the Catalyst state, because we are in the world of the Catalyst state. So what we can do here is substitute everything, everywhere we found an app state with Catalyst state. In particular, I found 2 points, 2 important points that are where we use the app state. The first one is the middleware, of course, because it's a middleware of app state. And the other one is the store, that it's one point, but it's passed along all the files inside the package. So we provided the substitution, and of course, we will have some problem when we try to build the main application. Thank you, little friend. But at the moment, we want to solve our problems one by one, and we see that our package builds without any problem after the substitution, of course. Let's move to the final step of modularization, which is the build of the main application, and we will see, I think all of us face into this kind of error. Type of expression is ambiguous without more context, so that means everything and nothing to me, but we are clever. So we know that here there is a type mismatch. In particular, we changed the type of the cat list middleware from middleware of upstate to middleware of catalyst state, and this raises this kind of error. So how can we solve it? We can solve it basically with functions, I can say. So the solution can be create a function that has an input a catalyst of, middleware of catalyst state and returns a middleware of upstate. This is very simple, if you see, and very powerful. So the idea is to try together to write this kind of function, having in mind, of course, some type alias from ReSwift. The first one is this one, the dispatch function type alias, which is a function from action to void, and the other one is the type of middleware of state from ReSwift. That is a lot of complicated things, but we don't have to have in mind all this definition. We just have to remember that this is a function that takes two parameters in input. The first one, which is a dispatch function, and the other one, which is a getter of the state. So our function will be a function that returns a function, because a middleware, we just said that it's a function, of course. A function with two parameters. The global dispatch function, I want to mark it as global in order to make the code cleaner and understandable, and the global state getter. The idea is that we should use those two parameters, pass them as parameter to the input, which is a middleware of local state, in order to compute the global state, the middleware of global state. To do that, of course, we don't have to do any transformation to the first parameter, because the type we see above, it's a dispatch function. So it's an action to void and doesn't involve any state. But for the second parameter, which is a global state getter, for sure we should find a way to transform the global state retrieved by the getter and transform this global state to a local state. To do that, we need another parameter, which is a key path from global state to local state. And now we are ready to write our function, which will be this, basically. So, as I said before, the first parameter is still the same. The second parameter, instead, it's executed in order to have the global state. Then we will use the key path in order to transform the global state in local state, and then we enclose it in a function in order to have a get of local state. The result is that this, it's called pullback. It's called pullback for mathematical reasons, and it's called pullback also by the guys that inspired me to do this kind of function. And maybe they call it pullback because it's something that it's a way of contrary of the map. We are pulling back from a global, from a local point of view to a global point of view in this way. In fact, we pass from middleware of local state to middleware of global state. If we run it, we will see that passing from this to this solves our type issue. But remember, we changed the middleware and in the module we created, and we changed also the store. In fact, we have still one issue to solve, which is the store. It's almost the contrary of the previous one. In fact, here our view is expecting a store of a catalyst state, but we have a store of app state. So let's try to solve it in the same way we solved the first problem. We need a function again, from store of app state to store of catalyst state. We have in mind again the type alias from ReSwift for the reducer, but we know that is a function from action with two parameter, action state and return state. And we compute the new function this time as extension of the store. So this is very simple. We just create an initializer of the store, which takes in input two parameters, the reducers and the initial state, of course. For the initial state, we use the key path in input in order to map the global one to the local one. And for the reducer, what we do is dispatching the action through the global reducer, of course, and then return the state mapped using the key path. Very easy. This works. We are ready to run our application and see what we created. Unfortunately, this is the result. The application doesn't work anymore. This is a little bit unexpected, maybe, or maybe not. But what we can do here is try to understand why this is not the correct way to do it, with the ReSwift, I mean. And let's try to find another solution to our problem. Let's come back to the old Redux diagram. Do you remember it? We have a local store inside our module, which updates through a subscription, a local view. The local view then, for example, when the view appears, dispatch an action which is received by the local reducer. But you saw before, in the slide before, the local reducer is defined dispatching an action to the global reducer, and then return the state applying a key path. So when the action is dispatched to the global reducer, the reducer updates the store. And then, if you remember, the store updates the view. But here, there is no view. It is subscribed to the store, because the local view is subscribed to the local store. So to solve the issue, we should find a way to make the local view subscribing to the global store. But we saw we can do it because the store is something that is in the app state world, so in the global world. So this approach cannot work. Let's find a different solution, which can be, for example, thank you, little friend, create a wrapper. So let's introduce local store, which is a wrapper by definition. It has one property, one immutable variable for each function we want to wrap from the store. In this case, I put the dispatch for dispatching, the get state for the state, the subscription and the unsubscription function, and then implements one function, of course, in which we will call the immutable variable, of course. How can we use it? Let's go back to our old solution. So instead of returning a store, we can return it here a local store, and then we can compute the local store in this way. So, of course, we need again a key path in order to transform from global to local, but now what we do is every time the local store calls dispatch function, calls subscribe, and so on, what we do is applying those kind of operations to the global store. It's very easy, I guess. And it's not only very easy, it works. And we call this kind of function view, because it's a sort of lens, let me say. We are focusing from the global to the local this time. And as I said before, this works. And we can use it in this way. So instead of passing the store, we pass the store.view, mapping the state, passing the key path, of course. This is the result. The application starts working anymore. It changes in white because I'm dynamic with colors, but it's okay. And that's it. So let's go with a summary. What we saw today. We saw ReSwift, the benefits, why we should use it, why we should implement a Redux architecture in ReSwift, and so on. We saw the benefits of modularization, isolation, interchangeability, and so on. And we tried to put together the two words by creating a pullback function to handle the middlewares, a local store wrapper in order to wrap the global store in a local point of view, and then the view function in order to assign the correct part of the store to the view, part of the local view, let me say. Those are two links, important links, let me say. The first one is the one to the repository of this project. I created two branches. The first one, develop, it's not modularized. And you can find another branch which is feature modularization. Inside you can find the modularized code working. The second link, it's the one to Pointfree Composable Architecture, because they inspired me a lot to create this talk. So I suggest you to follow the guys and follow their videos, because they are very smart. Question time. Thank you.